Good afternoon on this cold day. Today I'm going to show you how to use the software called Neuralworks, where we can design and test and run artificial neural nets. This uses an example problem called an iris network. And the example is, this is actually a flower. And they measured the length and width of the petals of the flower and the sepals. I think those are the green leafy part of the flower. So there's 4 measurements. And they did this for 3 different species. It's called Setosa, Virginica, and versicolor. So these were actual measurements made in a field of flowers somewhere in the Northeast. So we have a data set that has 4 input measurements correlated with 3 species. So that's our training set. What we want to do is create a neural net where we input those 4 values, the measurements, and use a neural net to classify into the 3 species. So there's the categories 1, 2, and 3. Throw some extra connection. So this data set already exists on Neuralworks in a directory, and we're going to use that data and train a neural net. Now there's actually 2 data sets in there. One is called iris PRN, and the .nna means it's an ASCII file for the neural net. And this has 72 training pairs of data. And then there's one called iris test, TES, and we're going to use this to test. In other words, we're going to train with this data. And then we're not going to train, we're just going to test to see how well it does on this extra data set. So I'm going to jump over to the software and show you how we will create this network. There's a series of menus that you go through to do this. So this is Neuralworks. The icon looks like this little picture in the upper left-hand corner. It's on the desktop. It's on the computers in John Bardo Center 255. So you have that available on those computers. Here's the launch screen. So we want to create a back propagation network to do the iris problem. So we say InstaNet, and then we say back propagation. And we get this menu where we tell it how many input neurons there are. There are 4. How many outputs there are. There are 3. And then we choose this, and I'm going to start out with 4 neurons that are in the hidden layer to do this. And I'm going to choose the delta rule over here. That's the normal backprop. And I'm going to use the sigmoid activation function. And I'm going to uncheck all of these boxes. Bipolar inputs has to do with positive and negative inputs. This data set is all positive measurements. The min-max table does a scaling of the data. The data is already scaled, so we're not going to use that. And connect prior connects the input layer directly to the output layer, and we don't want to do that for right now. We could, but we're not going to. In these 2 boxes here, we find the training and testing data. So for the learning column, we're going to choose training data set. And for the recall test, we're going to use the testing data set. And those are those 2 data sets that I told you about that are in the directory. And then we're going to click set epoch from file. And it's, sorry, I said 72. There's 75 training pairs. So it counts how many that are in that data set. It says that's going to be 1 epoch. And that's what we normally define as an epoch. Click OK. We say we want to track the RMS error. That's just the root mean squared error of the output error for the network. Click OK. And there's a plot here that's going to be generated, and I like to drag that bigger. And here's our network down here. 1, 2, 3, 4 inputs. The bias that we're going to talk about a bit later as to why it's there. And then we have our 3 output neurons and our 4 hidden layer neurons. So we created the network with InstaNet backprop, filled out that menu, said OK, and here we are. The next thing we want to do is run this file. That's done here. We say run, we say learn. And it's going to do it for 50,000 selections of data from the training set. And this is typically done in a random selection pattern fashion. A data point or a training pair is randomly selected from that training set, trained, and then another one's randomly selected, and it does this for 50,000 training pairs. You can change this number, but we're going to leave it as it is and say OK, and then watch the error plot. See the error go down, and we get down to 0.0386 RMS error. It's about 3.8% error. So that's fairly decent training. The data that's in that data set has those actual measurements of the iris flower, so there's some measurement error. So we wouldn't expect 100% results here. And then that testing data set, we can access by clicking on test under the run menu. And here we're going to say we're just going to go one time all the way through that data set and see how well it tests. And so we got about 0.147 RMS error. That's about 14%. That's not horrible. It's actually pretty good considering the measurement error. And what's actually happening is that it's misclassifying a couple of the entries because the data didn't match some of the training data. All right, we'll come back to this in a minute. Next, I want to show you how to save this network that we've just trained. Go to File, And the default place that it saves to is the current directory, which is the Neuralworks installation directory. When you do your own work, you'll need to bring a thumb drive, a jump drive, or use your personal drive on the computer. Change this directory by doing the double dots and then finding your drive in this and then saying, okay, I'm going to leave this as the current directory. And then to save our neural net trained, we'll do save as, and it's going to save it in that neural directory, that current directory, and I'm going to call it Iris Demo 1. Actually, just Dem 1. And notice you can save it as a binary ASCII or an annotated. Just leave it as default ASCII. And then the network is saved in that current directory. And I want to switch over to that screen. All right, so we're going to go find that directory. And inside this directory, the Iris Demo network was saved as a .nnd file. That's the extension used for when you save a neural net that's you've created and you're saving that neural net file, and then you can reload it. When we trained this and then tested it, it created a file called iris.tes.nnr, and this is a results file. I want to open that up and show it to you. So this is what that file looks like. It's the 3 target correct output values, followed by what the network actually output for those 3. So for this one, you can see it was supposed to be a 1 here. It's pretty close to 1, pretty close to 0, pretty close to 0 here. You go down, this is the next training pair. That worked pretty well. About 2/3 of the way down is one of the training pairs that got misclassified. And I'm going to see if I can find it here. Yeah, so here's one. It should have been a 010 classified as the middle species, and instead it misclassified it as a 0.82 over here in the 3rd category. And that's what led us to get a higher error for testing rather than training. And I believe there's another one we'd have to look through and find. I'm looking for this diagonal pattern. It goes like this. It should be 111 on the diagonal going down. And I think there's another one. I'm not going to take the time to dig it out and find it. So this is the results file that you get from testing. And so you can look and see, well, here's what I was supposed to get. And then over here is what I actually got. Okay, a couple other features of Neuralworks. Showed you how to save a file, a network. Showed you how to load in data, create a network. Occasionally you want to edit this RMS error instrument. You can change the colors, you can do all kinds of things. You can say it plots every 100 training pairs as the error, you can change that. to scale the data in and out. You can change the height and the width. You can tell it to plot stuff other than the RMS, although mostly what we do is this. And you can even set a threshold down here where if the error gets below a certain value that you type in here, it stops training, and you click convergence criteria here for that threshold. Let's see, so I told you how to save the network. Another tool that's nice to use is IO parameters. You go IO, you can look at the parameters. And this, if you wanted to, you could change the training and testing data sets by clicking here and then choosing the data set up here, clicking here and choosing the learning data set up here. Another thing to look at is that for learning, the radio button here, file random, is selected. That's what I was talking about. You can it randomly selects training pairs out of the training set. And for recall test, it does sequential. It automatically loads to RAM and creates a binary data set for faster input and output to help the program run faster. And later on in the semester, right near the end, we'll do a project where you'll have to use keyboard input here instead of from a file to test your network. I'll show you more about that later on. So that's another menu that's nice to have. And another thing that's nice to look at is this min-max table. Now for the iris problem, we did not create a min-max table. But if we had selected that we wanted a min-max table, it would tell us the minimum and maximum values for each of the inputs and the outputs coming in. Sometimes it's nice to look here and see, oh yeah, I expected the data to be within this range, and you can see the min and max, and you might catch an error in your data generation. Let's see, the only other thing that I want to show you is what does the training data set look like? So let's find that training data set. It was called iris tra.nna. There it is right here. We're going to open that with Notepad. We should be opening it with Notepad. Why is it locked up? Here we go. All right, so here is that training file here, rather than switching back and forth. So here's what the training file looks like. It's got the input data followed by the target. Well, that makes sense. That's what we used before. Input data followed by the target. Input data followed by the target. And notice the ampersand means continue. So this is all essentially one line. If the record is short enough, I tend to like to do that rather than do the ampersand, although sometimes there's a benefit. And then the data up here at the top with the exclamation mark is comments. So if you ever want to put a comment in your data set, put the exclamation mark, put the comment after that. You're free to use the ampersand if you want to continue a line that is one training pair is comprised of these two lines, or you can do it all as one line like this here. So that's the how the training data set looks, and we don't want to save that. I think that's everything that I wanted to show you about this program. You could feel free to open it up, play around with it, and we'll have an assignment coming up soon where you will be doing some homework, doing this iris data set for a bunch of other configurations.